Okay, in this next lecture, this next recording, we're going to take a look at some very simple exploratory data analysis and visualization using pandas on a very simple data set that just sort of popped into my head as might be interesting. I live in Allegheny County, and Allegheny County requires dog licenses for all of the dogs in the county, and it turns out that this data set of licensed dogs is public information. There's an organization called the Western Pennsylvania Regional Data Center that stores and makes available this information along with lots of other regional information. So let me copy and paste this. Now, I found this. I found this URL by simply Googling for Allegheny County dog licenses, and this is the URL that I found for accessing that information. So I'll copy and paste this. Actually, I'm not sure it will let me since I've got highlighting on, but whatever, we'll just go grab ourselves. Okay. Allegheny County dog license lookup. Allegheny County dog licenses, WPRDC, that's what I want. And there we go. Okay, so there is the URL, and here are the records of dog licenses. And I'm not sure exactly what the point is, but they maintain a record of dog licenses going all the way back to 2007. I'm interested in the current year. My dog is part of this database, and if I click on 2024 dog licenses, it shows me just the very beginnings of that data set. In this data set, we have an ID number, which turns out to be the license number that you need to have dangling from your dog's collar. The license type. This license type determines how much you have to pay for your license. If you are an individual and you own a neutered male dog, you pay a certain amount. If you own an unneutered male dog, you pay a certain amount. If you are a senior citizen or disabled person, and you own in this case, a spayed female, you pay a certain amount. All of these licenses are cheap. It's just a function that the senior citizen licenses are cheaper. All right. Well, I definitely don't want to interact with this database interactively on their screen. I can go up to the download button here and request to download the file. And it's got this hideous name. It lands in my downloads directory. And here is the hideous name that file has. ECEDB 5A4-48. Only a government bureaucrat would be able to dream up some kind of file name like this. But let me confirm that is actually in my downloads directory. Okay, there we go. So there it is. It's very difficult to see in the font here, but there is the file. Now, I find that a very objectionable file name. So the first thing I'm going to do here is to change this to Allegheny County Dogs 2024. Okay, this is the database of all the Allegheny County dog licenses during the year 2024. And now I can start pulling that thing in and analyzing it within Python. If you just use an ordinary terminal tool like more or type to display the file, this is what the beginning of the file looks like. So let's dive into using Python for this. Now, as I've said, I would prefer that you use, in fact, we're going to require to use Jupyter Notebooks, but it's hard for me to put Jupyter Notebook images in my course notes. Awful lot of graphics going on. So I'm going to cheat and continue using idle to illustrate how this stuff all works. So step one in analyzing and producing graphics for some new data set is to import the various modules that you think you are likely to need. So I am going to import NumPy as NP. Pandas is built on top of NumPy, and from Pandas I can use various NumPy facilities. So I'm going to import NumPy. I will also import Pandas as PD. So those are going to be my primary analytical modules. And then for plotting, I'm going to import a matplotlib.pyplot as PLT. And just for future reference, I'm going to go ahead and import Seaborn 2 as SNS. I'm not going to use Seaborn in this particular example, but we will be using Seaborn in the future. Seaborn gives you a few additional nice features above and beyond what matplotlib makes easy to provide. All right, so we've got our modules imported here. Then we are going to read in that Allegheny County Dogs comma separated value file into a data frame. We're going to hope that the CSV file is properly constructed so that readCSV, the pandas readCSV function, can successfully read it in without choking. You may have noticed, if I go back a couple slides here, that the ID here, which is the first column in this CSV file, is the actual license number. That's the number that's stamped on the little tag that your dog has to have on a collar around its neck. Okay? So those have to be unique. You can't have two different dogs that have the same license with the same ID number on it. So we're going to treat column sub 0 as the index column that has our unique index numbers in it. And that's why, whoops, pardon me, that's why I have added this additional keyword parameter, index call equals 0. So let's go ahead and see if that works the way we want. Okay, so I'm going to, into dog.df, dog data frame, I'm going to use pd.read CSV. All right, my first argument needs to be the path name where this file is located. Well, I am actually running idle in my downloads directory, so I don't need to type a full path name for the file. I can just go ahead and give the ordinary file name, Allegheny County Dogs 2024.csv. I hope that's right. Let me double check. Allegheny County Dogs 2024. Okay, so that is correct. And I'm going to make sure that the index column is set to 0 because column 0 in this file contains the license numbers, the unique ID numbers. And here we have dog.df. Notice that it is 66,778 rows. Each row describes one dog. And this, to me, seems like about the right size. There are something like 600,000 people living in the city of Pittsburgh, with some of the surrounding area. The overall population of the metro area is up around 1 million. And if we figure on average, this is probably too high, but figure 4 people per household, so you get around a 250,000 households approximately, and it appears that about 1 household in 4 has got a dog. So that's not proof, but that's some kind of indication that this number is not completely absurd. Okay, and then for each dog, we have the ID number. That's the license number. We have the license type, as I mentioned. And the license type contains a bunch of information that it would be nice if we actually had in separate columns. So the reason that dog, individual, neutered, male is all stored together as license type is because that combination of attributes determines what you have to pay for your license. It would be convenient if we had a separate column to indicate gender, whether the particular dog was a male or a female, and it would be nice if we had a separate column to indicate the, I guess what we'll call the fertility of the dog. So, we could have a column labeled fertile that was either true for all the unneutered dogs or false for the unneutered dogs. Okay? We have the breed of the dog as reported by the owner. They do seem to have done some cleaning up on these breeds because they do have Jur space Shepherd in all caps as the breed name for German Shepherds. There are not multiple different spellings of variations on German Shepherds in here. Then at the tail end of each line here, we have the expiration year. Of course, these are 2024 dog licenses, and so they will terminate at the end of 2024. And we have the date upon which these licenses became valid. So several people ordered their 2024 dog licenses early in December of 2023. Okay. Now, you'll also notice that we've got these 3 dots here, and that implies that there is some stuff that's not being displayed. There are some columns that are not being displayed because of formatting issues with Python data frames. So let's fix that problem now. Okay. Now, I just displayed the entire data frame and saw that there were 66,780 rows. You could also determine that by looking at the shape of the data frame. So 66,778 dogs, and there are 7 attributes per dog. Currently, only 6 of those, or maybe just 4 of those, are being displayed. So there are some attributes being hidden. Head can be used to show you the top part of a data frame. By default, you get 5 rows, but you can specify an alternative number of rows as an argument if you wish. And then tail is the opposite of head and shows you the bottom of the data frame. So if I say dog df dot head, I will just get the top 5 lines. All right, here's the first 5 CMU ID. My mistake. Here are the first 5 dog license ID numbers for the first 5 dogs in the file. Okay. Well, I would like to see all of the columns of the data frame that I'm currently interacting with, because after all, I'm exploring this data frame, and so I don't want to have things hidden from me. Now, you can use Google to find out how you go about seeing all of the columns in a data frame. I thought it would be amusing to use Copilot instead. So let's see what we get with Copilot. Here's Copilot. I'm going to ask, let me make sure I get my question correct here. In Pandas, see all columns of a data frame. In Pandas, see all columns of a data frame. And Copilot comes back and says, aha. To see all columns of a data frame, you can use set option display.max columns none. And I assume that setting that option value to none basically is equivalent to, infinity. It will show you all of the columns if you make this setting. So let's try that. I'm going to say pd dot set option and this is display.max columns, display.max columns, and I'm going to set this to none. Now that that has been accomplished, let me reuse dogdf.head to look at the first 5 rows. And okay, so each of these rows is wide, so it's not able to display the entire row on a single line. What it's doing here is it's displaying the first half of the first 5 rows, followed by the second half of those same first 5 rows. So we've got the the license type as our first data field here. Then we've got the breed of the dog as the second field. We have the color of the dog, third, and the name of the dog, fourth. Okay? Owner zip is the zip code where the owner resides, and expiration year is 2024 for all of these records, because that's when the 2024 licenses expire, and you have to pay for 2025. And then here are the valid dates on which people actually made their payments, so that you can see that these first 5 records in here indicate that people paid for these licenses on December 5th. If you look toward the tail end of the data set, which I can do with tail, dogdf.tail will show me the bottom 5, and you'll notice that a lot of these licenses that were granted later were actually overdue. You get an upset letter from the county auditor if you fail to submit your payment for your dog license on time. So we've got the people at the trailing end of this are just finally getting their licenses paid for in February. All right. Now, I can find out all the column names in a convenient list form by, let's see, dogdf, giving the data frame name, and then dot columns. And here are the names of all the columns. Now, I can access individual columns from here by saying dogdf sub and then give a column name. So this is going to give me the breeds of all the dogs. It won't show me literally all of the dogs, so at some point there will be the 3 dots to indicate that a whole bunch of stuff is being left out. There we go. So I got 5, and then I got my 3 dots to indicate the things that we're just going to continue leaving that middle stuff out. I end up getting the first 5 dogs and the last 5 dogs from this. I can also request what the data types are of each of the columns in the data frame. And you may or may not remember this, but if I ask for, if I ask for dogdf dot dtypes, I will get told the data types for each of the columns in this data file. And these data types are mostly object, which tends to mean string. So generally, when you see that the D type of a column is object, that implies probably that they're strings. 2 of the columns were interpreted as 64-bit integer data types. They are actually the zip code and the expiration year, so they're not actually a meaningful part of the data. Computing the mean and the standard deviation of the zip codes would not be very interesting, and computing the mean. The mean of the expiration year is just going to be 2024, and the standard deviation is going to be 0 because they're all 2024. So this data set, and therefore this data frame, suffers from not having a whole lot of meat to do interesting numerical statistical analysis. But we can do things like histograms and bar charts and of counts of the various breeds, the various colors, and so forth. Here is my index showing all of the column names that exist. Now, I can actually make a copy of this list within the index, and I can paste a modified version of that list There we go. Whoop, what happened? There we go. I can paste a modified version of that list inside of the column lookup. This is now a so-called fancy index. So I'm saying from my dogdf data frame, I want to create a new dogdf data frame that leaves out the expiration year and the valid date. I don't really care about the expiration year for the student, and the valid date, I assume, is just I'm sorry. Yeah, so valid date, as we've seen, is the date and time when you got your payment in so that your license became valid. Alrighty. And so this operation, dogdf of these column names, will return a copy, a reference to a copy of those underlying columns. I have also added the .copy method so that my revised dogdf will only contain a copy of those 5 columns from the original dogdf. And now if I display dogdf again, dogdf will not have those 2 columns in it. I suppose I'd better actually do this to demonstrate that that's happening. So, all right, so dogdf is going to get dogdf sub, and then I've got nested nested square brackets because I'm using a fancy index. Let me just copy all of these columns up to, but not including, the expiry year and the valid date. Okay, copy these things down here. All right, so we are doing a fancy index, getting the license type, breed, color, dog name, and owner zip code out of the dog data frame. And we're actually going to make a copy of those things into a revised dogdf that no longer has those 2 fields. We no longer have the expiration year and the valid date in our revised data frame. Alrighty. Now, if I just wanted to know all of the breeds for all of the dogs in my data frame, I can simply look up what's called the series, the column, for that particular attribute, the breed of the dog. All right, so I'm going to say dogdf is sub, and then let me look up the breeds of the dogs. This is going to give me every breed of every one of these 66,778 dogs. Okay, so let's confirm that. And all right, we see the same thing happen here that we saw with the columns, which is that there are so many rows that the data frame chooses only to show me the first 5 and the last 5. I could patch that up with another option setting, but I won't worry about it here. Okay, so I'm getting here the breeds of every single one of these dogs, and of course their license number is the label for those rows. Okay, now rather than seeing each of the individual breeds of each of the dogs, I can use another function. I guess this is vaguely statistical, but not very statistical, that counts the number of occurrences of each value that occurs for the breed. Okay, so I'm going to now say dog df, come on, dog df dot or sub breed sub close square bracket, and then value counts. All right, so this is going to give me a cumulative sum of the number of times that each different breed value occurs, and these will automatically be sorted from most common to least common. All right, and of course there are 66,778 in total, but I'm shown the top 5 and the bottom 5. All right, so apparently in Pittsburgh, in Allegheny County, there is only one Swedish Valhund and only one Canadian Eskimo dog. But we've got 8,000 mixed breed dogs, 3,700 Labrador Retrievers, 3,600 lab crosses, lab mixes, and 2,550 Golden Retrievers. One of these guys is mine. And then German Shepherd next, and on and on. I did not frankly know that the Golden Retriever was so popular. I didn't expect it to be one of the top 4 breeds. Anyway, if I'm only interested in knowing the most popular ones, then I can use head to select out just the most popular 5, or I could use head with an argument if I wanted to see, more than 5 or fewer than 5. All right, so just for gags, let me say head 7. That's going to give me the 7 top values, right? Mixed, Labrador Retriever, Lab Mix, Golden Retriever, German Shepherd, American Pit Bull, and Golden Doodle, which is a cross between a Golden Retriever and a poodle, if you weren't aware. And once I have got that data collected and structured, I can directly feed that. Where's my mouse? Come back, mouse. Okay, well, my trackball got stuck somehow, so I had to bail out and try again. Okay, so I'm going to get the most popular breeds, and then I'm going to produce a plot of these. The kind of plot is going to be a horizontal bar chart. So bar H means bar chart, horizontal. I can add a title to my plot called Popular Breeds. If you were doing this in Jupyter Notebook and you type this into a cell and run it, assuming that you've typed everything up to this point, you will get a nice looking chart immediately. Since I'm using idle, I'm going to have to also execute plt.show. So let's give that a try. So I'm saying now dogdf breed.valuecounts.head7 dot plot kind is bar H, and title is, let me be consistent, Popular Breeds. Okay. Popular Breeds. Okay. And I need to say, in idle, I need to say plt.show in order for that thing to actually appear. And there we have it. The width of the plot isn't so great because it chopped off the the names of some of these breeds, but I can just drag it larger, and then I can see everything. So mixed breed here is by far the most common, followed by Labrador Retriever, Lab Mix, Golden Retriever, German Shepherd, American Pit Bull Terrier, and Golden Doodle in descending order. And we could produce a pie chart of this and a vertical bar chart of this and various other kinds of plots. All right, well, that was very simple-minded, but did show a bit about how to suck in a CSV file into a data frame, how to massage the data frame to make sure that your data frame has the columns that you want, and then a quick example of how to feed that data frame to matplotlib.pyplot to get a plot displayed. All right, so that is that.